Hi, grade 10s. So the last concept we looked at was potential energy. So we are going to actually continue our discussion on energy, but we're going to talk about kinetic energy today. So if you remember, the definition of energy is the ability to do work. So when we talk about kinetic energy, it's the ability of a moving object to do work. And moving is key here because movement involves kinetic energy. So when you think about a moving object, what factors contribute to its ability to do work? Well, right off the bat, you guys think work is equal to force times distance, but that's not the only thing contributing in regards to work. That force that you're talking about is actually, influenced by two key things. So if you were to think about, if you were to unfortunately get hit by an automobile, even if you're at a stop sign, like I have had happen to me, somebody rear-ended me. What are two big influences on decreasing your injuries? So what are your things that you want to change to increase your chance of survival? Well, that would be the mass of the object hitting you, the mass of you, and how fast they're actually going. Well, believe it or not, kinetic energy of an object depends on mass and velocity. So when an object is in motion, it gains kinetic energy. So if you were to think, about the fact that we know energy cannot be created or destroyed, it can only be changed from one form to another. So you can have potential energy, you can have kinetic energy, you can actually have both at the same time. And you'll actually notice this on a roller coaster. So as it goes up to its highest peak, where it's almost stopped right there, potential energy is actually quite high. It's barely moving at that point, so the kinetic energy is low. So as kinetic energy of an object decreases, so as EK goes down, and we use EK to represent kinetic energy, EP goes up, and vice versa. If EP is to decrease, EK, kinetic energy, because it's gaining speed, is going to increase. Okay, and we see a lot of this when it comes to our next topic of efficiency. So our formula for kinetic energy, EK is equal to 1/2 mv squared. EK stands for kinetic energy. The unit is in joules. M stands for mass. Unit is in kilograms. So if you get a question in grams, you have to convert it to kilograms. Okay. And velocity of an object, meters per second. For this year, we're going to keep your velocity in meters per second, but in Physics 20, you will see questions in kilometers per hour and have to convert them. So just another way to write this formula here. Some people prefer this preference. So some people like to write it like this. 1/2 is the same thing as saying divided by 2. Personal preference, if you like this one, write it down on your formula sheet, use it. It's the exact same thing. Other people don't like fractions, so they write it as 0.5 mv squared. Also works. Okay, so pick the one of your liking. Okay, so just for our math algebra reasons, this formula can also be manipulated. So that means if I want to solve for something other than EK, and I still prefer to use my algebra methods, but if you don't love them, let's say you need to solve for M. Okay, so this is the one that you need to get on its own. So I can do that, by getting rid of the 1 divided by 2. Okay, so I'm going to multiply this side by 2. So EK is equal to times 2 is now equal to mv squared. Okay, because when I times by 2, that gets rid of that. Okay, now if I'm solving for m still, I need to get rid of v squared, which means I need to divide by v squared. And if I divide one side by v squared, I divide the other. So m, if you're looking for it and don't feel like doing algebra, this would be the formula that you use. You cannot forget about this squared part, okay, which means to the power of 2. Also, another way to write it, 2ek divided by v squared. Okay, so that's if you want to solve for m. If you want to solve for v, start off the same way. You need to isolate v, so I'm going to move the 2 to the other side again. So 2 times ek to get rid of the 1/2. Okay, that means I'm left with mv squared on this side. I want to get v on its own, so I'm going to divide by m. I divide one side by m, I divide the other. So I'm left with 2ek divided by m. Now, this is equal to v squared. We know that we cannot actually have an answer for v if it's v squared. So how do you get rid of a squared? You actually take the square root. So 2ek divided by m, you take the square root of this whole thing, and it's equal to v. Okay, so these are the two manipulated solving for m, solving for v if you'd like them. So, questions, of course. How much kinetic energy does a bullet have traveling at 400 meters per second if it has a mass of 0.016 kilograms? Velocity is 400 meters per second. Yes, bullets travel extremely fast. So, my units are in kilograms, looks good. Velocity is meters per second. I can now write my formula, 1/2 mv squared times 0.016 times 400 meters per second. But I have to square that. Okay, I really recommend you do that right off the bat. It's really easy to forget about it. And so if I put this on my calculator, make sure you only square the 400, not square all of the numbers. Okay, so I really suggest you type in 400 squared equals, and then times by the other two. Should get 1,280. Check your calculator, make sure you actually can type that in right. And with significant digits, I actually only get 2, 1, 2 here. So I need to change it to 1.3 times 10. I've moved the decimal 1, 2, 3 places. Joules, this has become a 3 because the 8 makes the 2 round up. EK. Hey, first example done. Second example, if a flying chicken, because we know chickens can totally fly, is traveling at 6 meters per second, I am going to write my zeros because sig digs matter. So if that chicken is flying that fast, it has kinetic energy of 64.3 joules. What is the mass of the chicken? So if you want, use the manipulated one formula that I gave you in the last 2 slides ago. I'm going to do it algebra way. So if this is your preferred method, you're going to get this demo. 1/2. I'm looking for m, so I'm going to leave it as m. And velocity is 6.00 meters per second. Squared. I like to simplify this right off the bat, so I'm going to go 1/2 m, and I'm going to make sure I square this, so that's 36. And now I'm going to go 1/2 times 36 just to keep things simple, which is 18. 64.3. And how do I get rid of multiply? I divide. You could have done this algebra a couple different ways, but this is the approach I took this time. And m should equal to 3.5722 kilograms. I get 3 sig digs based on my numbers originally, so 3.57 kilograms for mass. Oh, forgot the kilograms. Okay. If a 200-gram ball, so this is mass, has 300 joules, that's my kinetic energy, how fast is it moving? So I'm going to pause. I didn't pause on the other ones, but am I allowed to have mass in grams? No, I have to put it into kilograms. So little side math conversion. If I want grams to go into kilograms, so I want kilograms on top. That's what I want. How many grams? So kilograms on top. And I need to get rid of grams. And there's 1,000 grams in a kilogram. So 200 divided by, that's what this means, times 1 over, which divide 200 divided by 1,000. So I get 0.200 kilograms. Basically, if you don't like that method, divide by 1,000. Same thing. All right. So EK is equal to 1 squared. I'm solving for V. So 330 joules, 1/2. Mass is 0.200 kilograms, and V squared. So I'm going to do this math. So 1/2 times 0.2. Okay. And I should get 0.1 V squared. If I need to get rid of a multiply, I divide. And I'm left with V squared. And 30 divided by 0.1 should give me 300. Okay. But this is not my answer because this is V squared. I actually have to take the square root of it to get V, which gives me 17.32 meters per second. I get 2 sig digs, so 17 meters per second is my velocity of that ball. Okay. Bob and Nancy have the same amount of kinetic energy. Nancy is running twice as fast as Bob. Compare Nancy and Bob's mass. Usually you guys get these questions, you're like, what? There's no numbers. Well, there actually is. Same amount. So that means they both have the same EK. So in these fun situations, you get to pick a number. I like to pick nice, easy numbers. I'm going to say they both have 100 joules. That's the same amount of kinetic energy. This is going to be Bob. This is going to be Nancy. Notice I'm going to label my work. And now it says Nancy is running twice as fast as Bob. Well, let's say Bob is running 5 meters per second. Then Nancy is running 10 meters per second. I picked meters per second because that's our units we like to have velocity in. It's asking you for the mass or to compare them, which means I need to know the mass of both in order to compare. So this one I actually have to do 2 calculations on. I'm going to solve for m, 100, 1/2 mass I don't know, velocity is 5 meters per second squared. So I'm going to go 1/2 times 25 25 divided by 2 is 12.5 times m, and I got 100 divided by 12.5 to get rid of it because I need to get m on its own. Or like I said, don't start here, start with the manipulated one I gave you. Go back and get it if you're regretting your choice now. And you should get I believe 8 kilograms. Right? So there's Bob. Now let's look at Nancy. Nancy, same process. 100 joules, 1/2 m. The velocity though is 10. So this is 1/2 times 100. And half of 100 is 50. Sorry, I'm trying to keep this fast so you don't have to listen to my video excessively long. Divide by 50, divide by 50, and mass is 2 kilograms. Okay, thing is, yeah, some of you guys will stop here, but you're not actually comparing their masses here. If you picked other numbers, your masses would be different. So if I'm comparing them, well, Bob's is 8, Nancy's is 2. I know that's not realistic. It's just because of the numbers I picked. But what I do notice about the comparison is that, okay, Bob, you could tell me, has a mass 4 times larger than Nancy. That's a comparison. That's what the question's asking you. All right. Last example. A quarterback throws a 0.430 kilogram football to a receiver. So that's mass. At its peak height, the football is 5.63 meters high. Ooh. That's h. And is moving at a speed of 22.1 meters per second. What is the total energy? Now, in this case, it didn't ask for EK or EP. It's asking for total. Well, total energy at that place in time, that football actually has kinetic energy, and it also has potential energy. Okay? So, you have to find EK and EP. So, I like to find EP first. Why? Why not? MGH. Mass is 0.430 kilograms. Gravity is 9.81, or G is 9.81. And you'll notice it's per meter second squared. That there's not a squared on the G. It's not you squaring it. That's just part of the units because it's acceleration, it's gravity. So don't fall for that. And the height is 5.63 meters. So we're going to type that into our calculator, and we should get 23.749029 joules. Do not round until the very end. Okay, so there's potential. Oop. We haven't done kinetic yet. EK, 1 FMV squared. Mass is 0.430 kilograms. And velocity is 22.1 meters per second. We have to square that whole 22.1. And so I should get 105.00815 joules. So my total energy is EK plus EP because energy is constantly being converted. Okay. And I'm going to go ET for energy total. 23.74 7, 4, 9. I am going to just write the numbers for now. I'm going to include them all when I actually do it in my calculator. 105.008. And I should get 128.757179. All right, sig digs. Looking at my original numbers, I get 3. So 129. 7 makes the 8 round up. Enter joules energy total. And that is it. Okay, guys, so that's kinetic energy. And yes, kinetic energy and potential energy relate to each other. I hope we made that clear. Let me know if you have any questions. Have a good rest of your day.